A plane so advanced it bends its own wings, yet one engine flaw nearly brought everything crashing down. The Boeing 777X promises revolutionary efficiency and size, but behind the innovation lies a turbulent, costly engineering battle. Here's where it gets really interesting. Commercial aviation doesn't usually see fireworks. Most planes arrive in small, careful steps. Slightly better engines, a bit more range, minor cabin tweaks. The 777X isn't playing that game. From the moment Boeing announced it, this wasn't a refresh. This was a leap, a massive hold-your-breath engineering statement. Older widebodies like the 747 or even earlier 777 models were about brute force, 4 engines, heavy wings, and long-range muscle. But efficiency? Not always pretty. Airlines loved the 747's size, but hated the fuel bills. And then came the Airbus A380, offering mind-boggling capacity. But it was a nightmare for airport gates and costs. Boeing knew the market was screaming for the best of both worlds, a 380 level passenger capacity, but with twin-engine fuel efficiency that actually made money on long hauls. That's the heart of the 777X story. It's designed to carry hundreds of people further than ever, without burning your budget sky high. Think about it. Airlines aren't just buying a plane. They're buying survival on ultra-long routes, operational flexibility, and a chance to finally replace the aging 747 fleet without sacrificing profit. That's why the 777X isn't just another jet. It's a declaration that Boeing was ready to rewrite the rules of wide-body aviation. Boeing changed the script here, then. The 777X project was formally unveiled in November 2013. Boeing released 2 different versions, the 777-8 and the 777-9, rather than adhere to one model like most airlines would anticipate. Why? They hoped to strike 2 markets simultaneously, the ultra-long-range sector and the high-density, high-capacity roads. The range champion is the 777-8. A little bit smaller, lighter, constructed to travel further than anything Boeing had created in decades. Consider non-stop flights from New York to Singapore without working up a sweat. The 777-9 is the crowd pleaser, meanwhile. Greater fuselage, more dense seating, designed for busy lines such as London to Los Angeles or Dubai to Sydney. It transports more people, but compromises somewhat of the distance in the process. The rub here is, airlines immediately turned to the 777-9. The clear option for most carriers was due to its capacity, efficiency, and operating flexibility. Basically, the 777-9 emerged as the workhorse of the 777X family, while the 777-8 quietly rests as the long-range expert. Boeing's dual-variant approach allowed them to meet various airline demands without creating from scratch a whole new plane. Let's now consider the wing, since here the 777X earns its superhero cape. The heart of an airplane is the wing. It is not merely a wing. Boeing also approached it like a completely fresh design challenge. The 777X changes completely to carbon fiber reinforced polymer composites, following the same concept that drove the success of the 787 Dreamliner. Gone is the conventional aluminum frame. Lighter, stronger, more flexible, essentially a wing designed for contemporary times. The numbers are startling. With a wide increase adding considerable lift, the wingspan stretches to 235 feet, 5 inches. the aspect ratio rises from 9:1 to 10:1 as wing area grows and aerodynamic efficiency soars. Smaller sweep, view, greater lift-to-drag ratio? Indeed, every little modification is about squeezing more distance from every drop of fuel. Boeing optimized and adapted. They did not merely replicate the 787. The updated wing design lowers drag, increases cruise altitude performance, and lets the plane carry more fuel without adding unneeded weight. Airlines view it as absolute money in the air: more passengers, longer distances, and lower operating expenses. The wing is also the enabler for folding tips, which we'll get into next. But even without that, this composite revolution alone marks the 777X as a genuinely transformative plane, not just a shiny upgrade. Boeing managed to build a wing that's bigger, lighter, smarter, and it fundamentally changes what a twin-engine widebody can do. Wait, you're watching right now, but not subscribed to the channel. Go ahead and smash that subscribe button so we can move on with the video. You did? Okay, cool. Now back to the planes. And here's where the 777X gets downright clever: airport compatibility. It might sound boring, but this was a make-or-break challenge for Boeing. The plane is huge, way bigger than previous 777s. Most airports were built for planes under ICAO Code E, essentially a size limit for gates and taxiways. But the 777X in full spread is closer to Code F, the same giant category as the Airbus A380. Without a workaround, airlines couldn't even park this plane at many major airports. Enter the 11-foot folding wingtips. Simple in concept, revolutionary in execution. Once the plane lands and slows below 50 knots, the tips automatically fold upward. 20 seconds later, the wings shrink enough to fit existing gates and taxiways. In flight, of course, the wings are fully extended, giving maximum lift and efficiency. This solved one of the biggest mistakes Airbus made with the A380. Its massive wings locked it out of many airports. Boeing effectively gave the 777X the best of both worlds: Code F, performance in the air; Code E, practicality on the ground. It's a subtle innovation, but it completely reshapes how airlines think about operations, gate assignments, and long-haul scheduling. Folding wingtips aren't just a gimmick. They're a smart design decision that maximizes efficiency without forcing airports to undergo costly upgrades. Boeing essentially rewrote the playbook for large aircraft operations, and it's one of the first times you can see engineering directly solving a logistical nightmare. Boeing addressed fuel and range just when it appeared the 777X could not get any smarter. With far more fuel than prior 777 versions, the 777X can power ultra-long-haul flights that airlines have long been dreaming about. That additional capacity is about flexibility, not only distance. Airlines can now fly straight from centers such as Dubai or New York to almost everywhere without being concerned about refueling locations. More weight, though, results from more gasoline. Composite wings and structures enter here. Boeing saved thousands of pounds by replacing carbon fiber composites with aluminum, therefore compensating for the heavier fuel load and bigger wings. It's a delicate balancing act, adding capacity while maintaining efficiency. The outcome: an airplane that gives efficient intelligence above brute force range top priority. Every design decision is about doing more with less: longer flights, more passengers, cheaper operating expenses, without falling into the trap of just constructing a heavier plane that burns fuel like crazy. Let's now consider power, since the 777X would not exist without its core, the GE9X engine. Boeing picked General Electric only since it required an engine large enough and fuel-efficient enough to propel an aircraft of this size without consuming excessive amounts of fuel. Development expenses totaled more than $2 billion for GE, which produced one of the most sophisticated turbofan engines ever made. Larger than the fuselage of a Boeing 737, the GE9X has a fan of 134 inches. It employs 16 carbon fiber composite fan blades instead of the 22 present on the GE90, therefore decreasing weight and drag while increasing airflow and efficiency. Rising from 40 to 1, the high-pressure compressor offers an astounding 61:1 pressure ratio that permits hotter, more efficient combustion. Though operating levels are lower to guarantee long-term reliability, the engine reached 134,300 pounds of thrust during testing. A 10:1 bypass ratio lowers emissions to roughly half the present regulatory limitations, decreases noise, and improves propulsive efficiency. Overall, the GE9X offers an approximately 10% decrease in fuel burn over the GE90-115B. On ultra-long-haul trips of more than 8,000 nautical miles, this means thousands of tons of gasoline saved each aircraft annually and about 10,000 metric tons less CO2. Total efficiency increases by 12 to 13% when combined with the lighter composite airframe and new wing, or about 20% per seat compared to the 777-300ER. Passenger comfort is also redefined by the 777X. A bigger cabin provides genuine 18-inch economy seating, bigger dimmable windows, lower cabin elevation, greater humidity, and calmer acoustics. These elements combine to improve long-haul flights, transforming the 777X into a sophisticated long-range experience rather than merely a transport vehicle. Though nothing about the 777X has been normal, the first flight was meant to be a simple landmark. Originally intending to be in service between 2019 and 2020, Boeing had its timelines pushed back by the sheer size and complexity of the aircraft. Finally, on January 25, 2020, the 7779 lifted off for its first journey, a 3-hour, 52-minute journey from Boeing Field. Engineers rejoiced, but the difficulties were still far from over. The GE9X engine's durability problems almost immediately became evident. High-pressure compressor stator vanes were not operating as expected, which caused early wear. 4 of 8 compliance engines were recalled by GE for redesign, and Boeing had to change test schedules. These weren't small modifications. They postponed certification and drove the official service date further into late 2020. Every test cycle showed the delicate balance between great engineering goals and real-world dependability, even after the first flight had passed. Just as Boeing believed the engine issue was past them, problems reappeared. A GE9X engine abruptly switched off during regular testing in November 2022, causing a halt throughout the test fleet. Borescope examinations turned up a combustor liner failure, the exact element handling great heat within the engine. It triggered industry-wide concerns rather than only a technical glitch. Airlines such as Emirates voiced public worry, asking if this was a batch issue or a systematic design defect. Post-certification problems are particularly hazardous as the aircraft is already approved to fly. Any fresh issue could cause fast grounding, insurance difficulties, and FAA inspection. And with the lessons from the 737 MAX still fresh, regulators were not taking chances. Testing stopped as engineers examined, changed, and verified solutions. Flight campaigns restarted only after thorough inspections, but every new GE9X hiccup lengthened the schedule by months or weeks, showing just how high the stakes were for the 777X. Boeing had to manage safety, certification criteria, and customer expectations all concurrently. Every time there was a delay, it reminded me, building the most sophisticated twin-engine widebody in history requires great operational and technological pressure. Just when Boeing thought it had mastered the GE9X problems, August 2024 hit like a thunderbolt. After engineers found a broken thrust link on one of the planes, the whole 777X test fleet was grounded. That, for many people, might sound like a little bit of metal, but in an airplane like this, it's absolutely vital. Thrust links are heavy titanium components that transfer the engine's enormous forces to the wing. Without them, the connection between the engine and the aircraft is compromised. Even worse, the problem wasn't isolated. Inspections revealed vibration-induced cracking across multiple test aircraft, meaning the issue was fleet-wide. Boeing had no choice but to halt all flight testing for 4 months, while temporary fixes were installed and full ground tests were conducted. Engineers eventually designed a complete thrust link redesign, moving far beyond the stopgap measures used initially. Internally, this was a shock. The thrust link isn't flashy, it's fundamental. A failure here touches every single flight, every certification process, and every customer promise. For Boeing, it was a brutal reminder that pushing engineering boundaries, like building the largest twin-engine widebody ever, comes with hidden, expensive, and dangerous consequences. The cost of all these setbacks? Eye-popping. In Q3 2025, Boeing reported a $5.3 billion loss, mostly tied to the 777X program. Of that, $4.9 billion was a one-time charge for certification delays, redesigns, and testing setbacks. CEO David Calhoun called it a reach-forward loss, meaning the money spent won't be recouped in the first 500 aircraft. They are effectively building at a loss to ensure long-term program success. Added up, and the 777X has already accumulated over $15 billion in charges. It's a strategic risk, not just figures on a computer. Although the financial setback is severe in the near term, Boeing is wagering that twin-engine efficiency, passenger capacity, and operational flexibility will pay out over decades once the 777X starts service. Analysts were baffled. Adjusted earnings per share fell nearly 94% under projections, pointing out how much the scheme has stressed Boeing's financial statement. Every delay, remodeling, and grounding adds to this truth. Boeing is overseeing one of the most pricey and sophisticated engineering projects in aviation history, not just building a plane. And the market, competitors, and airlines are all intently watching to see if this risk will finally pay off or result in Boeing with a long-term headache. The 777X has a lot of airline support in spite of the controversy. Led by Emirates with 205, Qatar Airways with 124, and Lufthansa also clearly in line, overall orders stand at 565 aircraft. The delays, however, compelled airlines to make difficult decisions. Many have had to reassess fleet plans, change flight schedules, and retain older aircraft. These choices have enormous logistical and economic repercussions. It's not only a nuisance. Meanwhile, Boeing has 22 aircraft sitting in storage, built but waiting for certification to clear. Lufthansa is expected to be the first airline to operate the 777X commercially, making it the launch operator after Emirates and Qatar set the stage with fleet planning. The ripple effect is clear. Even with strong demand, program delays strain airline logistics, test pilot schedules, and ground operations, showing that building the world's most advanced twin-engine widebody isn't just an engineering feat. It's a massive coordination challenge. And here's why the 777X isn't flying yet. The FAA isn't taking any chances. After the 737 MAX disasters, regulators are scrutinizing every detail, demanding peer reviews of supplier data and additional validation at every step. Every time a GE9X issue pops up, the clock resets. Engineers must retest, re-inspect, and document fixes before flights resume. This isn't bureaucracy for the sake of it. Each system, the wing, engine, thrust links, must meet safety margins far tighter than in previous decades. In practice, that means even small discoveries trigger weeks or months of additional work. Boeing can't rush it. Speed now takes a backseat to absolute confidence that the 777X can fly safely, efficiently, and reliably. Airlines, pilots, and passengers won't settle for anything less, and regulators know it. The Boeing 777X isn't just a new airplane, it's a stress test for modern aerospace engineering. Its wing, engine, and economics may redefine long-haul travel, but only if Boeing survives the delays, costs, and scrutiny. If it succeeds, the future of wide-body aviation changes forever.